All right, ladies and gentlemen, so now that Ms. Thomas had a chance to walk you through the motion stories, we're going to try interpreting some distance time graphs. So instead of starting with the graph, we're going to create our graphs using the data. And to practice this skill, we're going to use a digital tool. It's a different graph maker than we used in the last assignment, but we can open it up by clicking on the link at the top of the page. When you open it up, you should see this line graph maker. There's an ad at the top, but I've zoomed in here so that you can see what I'm doing. For each of the 3 data sets, you're going to follow the bullet points at the top, and we're going to do the first one together here. So for the first data set, our graph title should be the name of the data set, and in this case, that's data set 1. Our horizontal label, well, horizontal, that's the horizon, that's our x-axis. And we know that when we're doing these kinds of motion stories, our x-axis is always going to be time. And if we look at our first data set, our time is measured in hours. So we're going to include that in our label. The vertical axis, well, that's our up and down, that's our y-axis, and we are measuring distance. In our first data set, our distance is given in miles. So again, we want to include our label when we're putting things on our axes. What we need to do next, that bold red one there, the horizontal data type. Well, in this case here, we have values. We have X and Y ordered pairs. We have coordinates here. So we change it to values. Our data values are the X values that we're given. So in this first data set, we have 0 through 6. I'm going to type that into the box with a space between each X value. And we only have one line. We're just comparing time and distance for one person or one object, so we'll leave that alone. For our line 1 data values, well, that's asking us about our y-axis, our y values. So I'm going to do, just like I did for x, this time I'm going to type in my y value starting at the top going down with a space between each number. Now what we can do, and you don't have to, but you can change the color of the line. And I'm feeling kind of purple today. So we'll move over to purple and we'll choose a nice fun, there we go, nice bright purple. Not something you have to do, but makes it a little prettier by the end. Then we're going to hit draw. Once we've hit draw, we should see our graph down here at the bottom. And let's say we made a mistake. Let's say instead of hours, we accidentally put potato. I don't know. If I hit draw, it'll update my graph at the bottom. Now I have time measured in potato. Okay, well that's not right. So if I go back and change it, if I change this to hours but I don't hit draw, it won't update it. So same thing, if you update anything in the top, you need to hit draw and it'll change it to what you want it to be at the bottom. So now what we're going to do is we need to insert this graph into our document. And there's a bunch of different ways to do it, but I think the easiest way to do it is to hit, either way, no matter how you do it, you've got to hit this print button and it'll open it up in a new window. When it opens it up over here, it's an image, so we can drag and drop or copy and paste. When it's in this part here, it doesn't, the dragging, dropping, it doesn't work. But once you hit print, it opens it up in a new tab for you, and then you can drag and drop it right into the box. If you're dragging and dropping on a Chromebook, you can drag it and then like hover over the tab and then drop it where you want it to go. Or you can copy image, paste image, all sorts of different ways. But you need to insert that graph into your document. Then what you're going to do, it didn't actually insert this time for me. We'll paste it in there. There, my graph is inserted. Now I need to think about these analysis questions, and I want to make sure that I'm answering with complete sentences. We're working on our literacy skills here. That means I want to pay attention that I'm using a capital at the beginning and a period at the end, and I'm writing a complete thought. So where did the object start? So I'm going to start my sentence before I even worry about the science. The object started, the object started, and I've got to think about my ideas that Ms. Thomas talked about. If I'm at home, if my object is at home, I would be at 0, 0, at the origin. But in this case, I'm not at home. I'm at 0, 6. So the object started 6 miles away from home, or 6 miles away from our reference point. Now I want to know how fast is the object moving and what direction is it moving in. Well, direction is easiest. If I'm looking at the direction here, I can see that my line is going farther away from the x-axis, and that tells me that my object is moving away from my reference point, or away from home. But I want to know how fast it's going, and so this is where I need to bring in those math skills. What I can do is I can look at this, at my data table here, And I can see that for every 1 hour that changes, I see that it has grown by 6 miles. The fact that this is a straight line tells me that it's a constant velocity. It's moving at the same speed the whole time, and it's increasing by 3 every time hours increase by 1. Now on some of them, if we extend farther here, oh, I don't know if I can scroll down, done. I don't always have even increments. If I'm looking at these ones here, sometimes I have a change of 1, and sometimes I have a change of 2. So I need to look and compare that I'm only looking when I have a change of 1 hour. Every time 1 hour changes, I gain 3 miles. So the speed, the object is moving at a speed of 3 miles per hour away from home, or away from the reference point. Now I need to figure out, after 10 hours of travel, where would the object be? And there's 2 different ways that we can answer this. I'm going to show you one way, and if you know another way that gets the same answer, you can use that method. Well, if I know that it's moving 3 miles per hour and it's traveling for 10 hours, well, 3 times 10 is 30, so it's 30 miles away. But it started 6 miles away. That starting point of 6 miles away, I need to add that in. So it's 6 miles plus 30 more miles. So after 10 hours of travel, the object would be 36 miles from home. Lots of different ways to get there, but you should figure out that it should be 36 miles away. We can extend our graph or extend our table. We can write an equation, or we can use our knowledge of miles per hour times hours plus the original distance from home. So now your job is to do the same process for data set 2. Oops, let's close this out. And data set 3. What you're going to do is, when you're here, you need to make sure you change all of your values and then hit draw to update the graph below. The last step is to write descriptions of what's happening in these position time graphs. And it's similar to the one that you went through with Ms. Thomas. We want to talk about where the object's going and what's happening. In this case here, we don't have numbers, so we can't calculate speed, but we can talk about direction. Is it going to the reference point, or is it going away from the reference point? Is it in front of the reference point, or is it behind? When it has negative values for my y, I'm behind my home or behind the reference point. Am I not moving? If I have a 0 slope, it tells me I'm not moving. So with your descriptions, you should have at least 3 sentences, because you need to describe each piece of the graph. And each of these graphs have 3 separate segments. So type these out with complete sentences. And these ones need to be with complete sentences. You've got lots of practice today of using your literacy skills. Make sure that you insert your graphs. If you're having trouble, send a message over Teams chat and we can help you out. Ms. Thomas can help you if you're in her class, or I can help you if you are in my class. Go ahead, get this done, and make sure that you hit turn in or submit when you are finished. Thanks, guys.